In this video, we will use a bottom-up introduction to show how we build the rendering server. The core component of the system is a rendering engine. The engine employs the ray tracing algorithm to generate photorealistic images. Ray tracing is a compute-intensive task and have been ported to GPU to accelerate the process. However, the branch divergence issue reduces the level of parallelism and causes resource underutilization, which makes the performance to degrades rapidly. To fully utilize all available resource on the server, we introduce an adaptive runtime system, the heterogeneous queue. The heterogeneous queue system manages all tasks and assigns them to all available devices on the server based on their computation ability. The workload between devices can be rearranged. If a device is overwhelmed, the heterogeneous queue system will divide the excessive tasks to other devices. With this design, we can fully utilize every CPU and GPU on the server automatically to achieve load balancing. Next, we are going to improve the user experience by using the light field technique. With the help of heterogeneous queue, we can increase the speed of rendering. However, render the images one by one cannot provide interactivity or fast viewpoint switching. The users can only see from a fixed viewpoint, for example, the front view of the objects, but cannot change the viewpoint dynamically without experiencing delays. Comparatively, adopting the light field rendering technique allows users to explore the scene by roaming among viewpoints. To achieve that, only the predetermined frames are required. Mobile VR and AR is the future trend. We implemented the light field display on mobile devices. The system is designed as a client-server architecture to support multiple connections. The light field rendering is handled by the servers due to its intensive resource usage. After computation, the server will transfer the compressed images to clients. Finally, static images cannot fulfill the needs for VR and AR applications. In our system, we allow a certain level of interactivity. Users can interact with objects in the scene. They can move the objects to the new position, or add more objects to the scene. The change will be sent to the server. Then the modified images will be sent to clients in a short time. We also design an adaptive rendering scenario that drastically increase the performance, while keep the acceptable image quality.